The stopping distance of a vehicle is affected by several factors, such as tire tread wear, brake pad wear, and shock or strut wear. As a service technician, understanding these factors helps to ensure a customer's car is safe to drive in all conditions. Let's take a look at a few examples where we calculate stopping distance rates. The first example reads, a car with a tire tread depth of 11/32 inches, traveling 60 miles per hour, takes 2 seconds to come to a complete stop, skidding a distance of 189 feet. The same car under identical conditions, but with a tread depth of 3/32 inch, takes 3 seconds to complete a stop, skidding a distance of 386 feet. Find the stopping distance rate in feet per second for each case, rounding to the nearest tenth. Let's begin with the first car. Since they want us to find a rate that is in feet per second, we know that that first car traveled a distance of 189 feet within 2 seconds. So all we have to do is divide these two numbers out. 189 divided by 2 gives us a unit rate of 94.5 feet per every second. In the second situation, the tread depth was a lot smaller, so these tires are worn out. And in this case, it skids 386 feet per 3 seconds. Doing the same sort of calculation, where we take 386 and divide it by 3, we end up getting a unit rate rounded to the nearest tenth of 128.7 feet per second. 128.7 feet per every second. As you can see, the deeper the tread, the lower the stopping distance rate. Now let's take a look at another example, and this one is a little more complicated. A car with 11mm brake pads stops from 70 miles per hour in 229 feet over 3 seconds. Under the same conditions, but with 3mm brake pads, it stops in 487 feet over 5 seconds. In the first question, we have the same situation as before. Find the stopping distance rate in feet per second for each case. So let's tackle that first. For the 11mm brake pads, we have 229 feet over 3 seconds. And for the 3mm pad, we have 487 feet per 5 seconds. Using our calculator, 229 divided by 3 makes 76.3 feet per second. 76.3 feet per second. That's the stopping distance for the 11mm brake pads. And for the other one, we have 487 divided by 5. And that amounts to 97.4. 97.4 feet per second. So it's clear that as brake pad thickness increases, the lower the stopping distance rate will be. However, in question B, we're asked, using the two stopping distance rates found, how much better as a percent is the stopping distance of the car with 11mm brake pads than the car with 3mm brake pads? For this, we need to find the percent change. And the formula for percent change, if you recall from our previous lessons, is your initial value plus minus your initial value times the rate is equal to the final value. Now we'll be using the higher of these two rates as our benchmark value, or in other words, our initial value. So our benchmark will be the 97.4 feet, because that was the worst of the two. So that's our initial value, and our final value will be the 76.3. All we have to do is substitute those values into this formula and solve for the rate, which represents our percentage. So I'll put in 97.4 in for that I. And because our benchmark is going from high to low, we have to use the minus version of this formula. So essentially, we're calculating the percent decrease from 97.4 to 76.3. And that will tell us how much it has improved. So again, we'll replace this I with 97.4. R is unknown to us, and our final is 76.3. We have to rearrange this equation so that we have R isolated. We'll take that value, move it over, so that the constants are on the right side, and they can be subtracted in the next step. Now we'll subtract 76.3 and 97.4, and that amounts to negative 21.1. Don't be alarmed that there's a negative. That's completely normal. And now, to isolate for this R, we divide both sides by 97.4. Those two negatives cancel out, and we get an R value. Now, this is a decimal value, which needs to be multiplied. Notice we get a decimal output. We need to multiply this now by 100%, or simply a factor of 100, and we end up getting 21.7%, or roughly that much improvement from changing your brake pads that have only 3 millimeters of depth over to 11 millimeters of depth. So that is the improvement, a 21.7% improvement in stopping distance rate as a result of this change. If you have any questions, please leave them in the comment section below. Thank you for watching.